Hi everyone, in this video I'm gonna show us the function Softmax in NumPy and PyTorch in Google Colab. Now the Softmax function by definition is that it's gonna, if you have a list of number, let's say 1 2 3 4 5 for example right there, right, it's gonna take the exponent of each one of those numbers and is gonna divide that with the sum of the total exponent of those numbers. So let's say, right, if you have 1 2 3 4 5, it's gonna take the exponent of 1, exponent of 2, so on and to 5, right? And then it's gonna sum that those exponent, and then the softmax of 1, for example, or the first number is just the exponent of that first number, which is 1 in the situation, and and divided by the sum of the total exponent, uh, the sum of all of the exponent in the list right there. Okay, and you can see right here the softmax function kind of is relying on the natural exponent e to the x right here. And if you take a look at the graph of e to the x, you can see some property of the exponent, the exponent function right here. You notice that it's increased pretty quickly to infinitive. You can see right here, right? You go to 2, 3, 4, 5. It's already start zooming up pretty quickly, and then it never. It's always a positive function. It's never dip below 0. So you can see right here, if you go to -2, -3, or something like that, the number getting smaller and smaller, but it doesn't dip below 0. So how I got this graph is that I create a linear space using a linear space. I create a list of 100 number evenly spaced between -2 and 2 right here. And then for each one of those number in the list, I calculate the exponent e to the x using NumPy right here. And I plot it with x on the x-axis right here from this, and then y is the exponent right here. You can see right there, right? And by the way, this special syntax right here is latex that can give you a special kind of creating or printing special character formula in math right there. Let's make it look a little bit better. So if you want, you can find out more about latex, how to print latex or formula in Colab. It basically begin with money symbol and end with the money symbol right here. So so the softmax function, here's the definition of the softmax function, and it depends on the natural exponent. And by the way, e is 2.718 so and so on right here. Okay. Now I can give you an example of calculating the softmax for a list of number right here, 347, for example. So if z is equal to 347, and the way to do that is that we gonna compute the exponent for each of the number in the list right here, which is 3, e to the 3, e to the 4, and e to the 7, and we store that in the variable numerator. And after that, we do the sum of the numerator. You can see right here, right? Sum of the numerator in this situation right here, which is the exponent of the number in the list. And then the sigma, which is the softmax, is the numerator divided by the denominator. And you can see right here, right? So if you have 347, the sigma or the softmax calculation of these numbers are this, and this. And then you see that it'll add up to be about 1 right here. It add up to be 1 right here. Giving text some grounding up right number in Colab and Python. Now the interpretation of softmax is that you can think of this as converting the list of number into some sort of probability. You see right here, right? Because the sum of the softmax is going to equal to 1, and each one of those number softmax is going to be between 0 and 1. So you can think of that as a probability, for example, in deep learning, to classify this as a dog, this as a cat, and this as, for example, a bird, for example, right here, right? So you can use that, think of that as one interpretation So softmax basically converting a list number into some sort of probability distribution that we can interpret in a particular situation. For example, image classification. Okay, and then here is the another example of the softmax function. I create a random list of integer from -10 lower bound to upper bound 10, and the size is 15 right here. And again, right here, I'm just manually computing the exponent of each of the number in the list that I store in the variable z. And then for the denominator, I just sum up all of the exponent values right here. Okay, and the sigma or the softmax is the numerator divided by the denominator right here. And then we can plot the softmax function on using math.lib. I imported math.lib right here, see, and then here I plot it. I can give us the x label, z. I can give it a y label, sigma right here, the special character using latex right there. And then for the scale right here, I can plot it using the regular or logarithmic right here. Now let's look at this right here, right? If I do it regularly, I'm copying this out so that it wouldn't run the slide right here, Colab. You see that here is the plot in regular plot, regular scale. So the in this interpretation right here, the number 9, for example, right here, right, would have a higher probability than number 7, for example, and all of these would add up. All of these sigma right here would add up to be equal to be 1 right there, right? And then if you plot it on the logarithmic scale, for example, right here, okay, so scale is log right there. You notice that essentially in the logarithmic scale, it's just a linear transformation of the original number into the space right here, the softmax softmax right here. Okay. Now we can also do this in PyTorch right there, right? But it's a bit different. We have to instantiate an object using the softmax class right here from neural network, and I import that .nsn right here, that library. So and then we pass the data, the same data right here, z right here, to same data z right here into this sub object right here, and then it's going to calculate the sigma first, and we expect the sigma to be the same. You can see right here, right, when we plot the sigma versus the z value, you notice that it is essentially the same plot at the one previously when we're using NumPy instead of PyTorch right there. Okay, and by the way, for the math for the plotting right there, right, we can specify the color, for example, the color of the dot, and then the type, the shape of the dot, right? So if I change it to X, and then if I change it to K, for example, I think that's black right there. Let me run that again right there, right? So you notice that it will change it to X, and then the value is black right there. So this right here is an example of how to calculate the softmax function. It has its utility in deep learning. Hope you enjoy this tutorial. Please share, like, and subscribe, and have a good day. Bye-bye.